Hey all, welcome to Tutelinks. In this tutorial, I'll be demonstrating you how to deploy a FastAPI application on Ubuntu 18 operating system. Our FastAPI application will be performing create, read, update and delete operations on a PostgreSQL database. We will be running our FastAPI application on Gunicorn web server, which is configured to run as a systemd service. And we will be exposing our FastAPI application to the outside public internet, which is exposed as a reverse proxy running on a web server Caddy 2. So without further ado, let's get started. As we want to deploy our FastAPI application on Ubuntu operating system, let's grab a virtual machine that has Ubuntu. So for that, I'm on Microsoft Azure Cloud Platform dashboard. So I'll start off by creating a resource that has Ubuntu as a operating system in a virtual machine. So here I'm on the create virtual machine wizard. So I'll be creating a new resource group just to accommodate this virtual machine. The name of the resource group will be Tutelinks Ubuntu resource group, and the name of the virtual machine I would like to give as Ubuntu, and I'll be choosing the region which is very nearest to me. I'm located in India, so I'll be choosing Central India. And the image, this is an important step because we are going to create a Ubuntu virtual machine. You have to choose Ubuntu server. I'll go on with the default and very minimal size, which is a B1S for the sake of demonstration purpose. And that in authentication type, I'll be choosing SSH public key, and the username will be Vincent. And I'll be going to generate a new key pair, and the key pair name will be Ubuntu_key. And because I want to deploy our FastAPI on Ubuntu, I need to access this virtual machine in some form. That some form is nothing but secure shell, and for that I have to enable port number 22. As I also mentioned that we will be exposing our FastAPI application to the public internet, so we have to enable port 80 and 443. So once you are done with the deployment, you are recommended to disable the port SSH 22. But I'm not yet done with the deployment. I'll leave this enabled. Click on next to navigate to the disk tab. The disk tab, I'll be going on with the standard SSD for the demonstration purpose. In the networking, you see the public IP. Let it be a new IP to be created, and click on next to management tab. Disable the boot diagnostics because I am not needing it for the demonstration purpose. Disable the auto shutdown. I do not want to automatically shut down the virtual machine. And click on next to navigate to advanced tab, and then tags. And I do not have anything here. Click on review and create. Ensure that the validation passes. Yeah, the validation passed, and click on create. Finally create the virtual machine, and we have to download the private key so that whenever we want to connect to this virtual machine via SSH, we have to provide this private key as an argument. Sit back and relax because the virtual machine deployment is going to take at least 3 to 4 minutes, and we'll come back once it is done. Alright, so our virtual machine has been successfully deployed on Azure Cloud Platform. So let's click on go to resource, and here you can see the public IP address. And if we want to connect to this virtual machine through SSH, click on connect and click on SSH. It will show you the command to connect to this virtual machine. So here is the command. So copy it because we have already downloaded the private key. I'll be connecting to this virtual machine using PuTTY or command line terminal, but I will be using CMDER. So let me launch CMDER. CMDER is an open source and free tool that have the various shell capabilities like Windows subsystem for Linux, Bash, PowerShell, and the typical command prompt. So here I have opened the CMDER and I will be giving the command that I have copied over here, and the private key path I will be giving the path of the private key, the PEM file that I have downloaded. It is located at C users windy download and Ubuntu underscore key dot. So hit enter and type in yes for the prompt, and you will be successfully connected to the Ubuntu virtual machine. So let's look at the operating system details. So here we have Ubuntu and the version is 18.05, 18.04 and .5 LTS Bionic Beaver, and we have successfully connected to this Ubuntu virtual machine. So the next step we will be doing is to install and configure PostgreSQL 13 database, because our FastAPI application is performing create, read and update and delete operations on a PostgreSQL database. So for that, so all you have to do is type in the command sudo sh-c and down to the list, and you have to hit enter. What I'm doing is I'm adding the latest PostgreSQL repo to the apt, and I'm downloading the keys, and then I'll be updating the app. Yeah, and finally once done, I'll be installing PostgreSQL 13 on the Ubuntu operating system. So finally run the command sudo apt install -y PostgreSQL 13 and hit enter. Wait for the installation to complete. Alright, the PostgreSQL 13 has been successfully installed. Let's verify the version of PSQL we have got on our virtual machine. So it's 13.1. Alright, the next step is we'll be creating a DB named FastAPI DB. So for that, all you have to do is type in the command sudo su -space postgres space -c, then create DB FastAPI DB. The name of the DB will be FastAPI DB. Alright, we have successfully created the PostgreSQL database with the name FastAPI DB. Next, we will be creating a user. Alright. Now we will be creating a user named FastAPI user. For that, we have to type in the command as shown on the screen and hit enter. And as we have mentioned -p flag here, so we are supposed to provide a password for this user. So I will be giving the password secret, all lowercase, SECRET, and reconfirm. Yeah, So we have created a user, FastAPI user with the password. Now I will be granting all the privileges for this FastAPI user on the FastAPI DB. So for that, all I have to do is to run the command sudo -u PostgreSQL. The command will be grant all privileges on database FastAPI DB that we have just created to the user FastAPI user we just have created, and hit enter. So the grant is provided successfully. Alright, so we have Ubuntu virtual machine available, and it is installed and configured with PostgreSQL version 13 database. Our next step is to pull a FastAPI repository onto our Ubuntu operating system, and we will be cloning a publicly available FastAPI repository. And here is my FastAPI repository, and the branch that we are going to deploy on Ubuntu is FastAPI PostgreSQL Caddy Ubuntu deploy. So let me click on that branch. So this will be the full source code that we are going to deploy on Ubuntu operating system. So let's access the SSH back again, and we will be issuing a command to clone the repository that is available here. Here you can see git clone, and the repository will be FastAPI available on my username, and the branch, as I mentioned, will be the branch where our application code lies. That will be FastAPI -PostgreSQL -Caddy -Ubuntu deploy. So hit enter to clone our repository. Now if you see the contents, we have a directory named FastAPI downloaded from the GitHub. Let's cd into it and list the contents of this directory. Alright, so we have all the required files necessary to spin the FastAPI application up and running. Right. As we have cloned the repository, we will start off by creating Python virtual environment. So for that, all you have to do is type in sudo apt install -y python 3 -venv. So we are going to install this apt module because Python by default does not have venv available on Ubuntu operating system. So in order to facilitate creation of virtual environments, we need this package to be installed, available in apt. So hit enter. Alright, so now we will start off by creating a virtual environment. Python 3 venv and env. Ensure that you are in FastAPI directory, and the name of the virtual environment is env. Hit enter. Alright, the virtual environment is created, and let's confirm that. We can see that env is the virtual environment here, and we will be activating the virtual environment by giving the command source env/bin/activate. Alright, so you can see the virtual environment is activated, and we are within the virtual environment. And let's start off by running the sanity so that our application successfully runs by giving the command uvcom. Main is the module, and app is the variable to which FastAPI is initialized. Okay, but before that, all we have to do is our FastAPI application is dependent on certain modules, so which are present in the requirements.txt. So here is the list of all the modules that you can find that our application needs in order for it to run successfully. So we have to install all those dependencies within this virtual environment. But before that, let's look at the version of pip we have. Pip is the Python module installer, and we have the very old version of pip, but we have to upgrade before we can start installing all the dependent modules that are mentioned in requirements.txt. So for that, all you have to do is to upgrade the pip first. Run the command pip install --upgrade, and what we are going to upgrade, the pip itself. So we are using pip to upgrade pip. Quite funny and interesting. Okay, so we have successfully upgraded the pip from version 9 to version 20. Alright, so the next thing is we will be installing all the modules that are present in requirements.txt by providing the command pip install -r requirements.txt. Alright, we are good to go with running the sanity application now. So we will be giving the command 𝐂𝐫𝐞 module main and the variable to which the FastAPI is initialized with is app, and hit enter. Congratulations, but wait, we are not going to finish our tutorial right here. Let's stop our application because we want to run our application on a 𝐺Unicorn web server, and we will be configuring our 𝐺Unicorn web server to run as a systemd service. Alright, so far we have set up and configured all the underlying infrastructure to run our FastAPI application. Now it's time for us to run the FastAPI application with the help of 𝐺Unicorn. 𝐺Unicorn or Green Unicorn is a Python-based WSGI HTTP server for Unix. WSGI is Web Server Gateway Interface. Our FastAPI application runs on ASGI, which is Asynchronous Server Gateway Interface compatible servers like 𝐂𝐵CON and HyperCon. 𝐺Unicorn, being a WSGI web server, facilitates running FastAPI with the help of its worker class 𝐂𝐵CON.workers.𝐂𝐵CON_worker. We will create a systemd file by accessing the SSH terminal. We will be creating our systemd file using the nano editor at the location etc systemd system, and the name of the service that I am going to create will be 𝐺Unicorn.service, and hit enter. I will be pasting the contents of this unit file right from the repository. So here I already have checked in the service file, so let me copy the contents of it, and make sure that you replace the directory that reflects the installation of the FastAPI repository according to your directory structure in the execute start command. So let me switch back to the SSH again and paste the contents of 𝐺Unicorn.service unit file. Alright, I have successfully copied the contents of the 𝐺Unicorn service file, and Ctrl X, capital Y, and hit enter to apply the changes. And we are ensuring here the contents got pasted properly in each and every line they own. So we have created a systemd managed unit service with the name 𝐺Unicorn.service. This could be any name of your choice, like FastAPI.service. I have given 𝐺Unicorn.service because this unit file we have created can not only be used for FastAPI but can also be used for Flask or any web framework that supports 𝐺Unicorn web server. The only difference lies in the way we spin up the application using the command held by execute start directive of the unit file. For the Unix beginners, unit files are the configuration files managed by the systemd that hold the behavior of a specific service that we are dealing with. They get added as services and allows various capabilities to start the service when a system reboot happens or retry restarting the service in case of failures, and offers various other capabilities. If you notice, the path for exec start directive is having env in its path, which indicates the name of the virtual environment. If you have given a different name for your virtual environment, you can replace env with the name of your Python virtual environment. The 𝐂𝐿 unit file uses the 𝐂𝐿 binary available in the virtual environment installed for our FastAPI to run. The version of 𝐂𝐿 binary is based on the version of 𝐂𝐿 mentioned in the requirements.txt file. If you look at the exec start directive of the 𝐂𝐿.service file, we are providing the 𝐂𝐿 binary with the location of the configuration that holds various arguments in the form of literals enclosed in a Python file named 𝐂𝐿.py. That is also available in our repository. So let's take a look at the 𝐂𝐿.py file. We have 𝐂𝐿.py file wherein we have provided all the configuration. So I am importing the multiprocessing module here just to build the number of worker processes here according to the standard formula provided by 𝐂𝐿 configuration. So it's nothing but the number of CPU count multiplied by 2 and then incremented by 1. So at max it will be able to process these many worker processes to be run by the 𝐂𝐿 master service. So the worker class is the asynchronous 𝐂𝐿 worker class, and the number of worker connections and the rest of all the arguments that are going to be passed to the 𝐂𝐿. And I'm loading the default configuration values from the load and here is the environment file where I'm setting various environment variables, and that's about it. So let's look at how many worker processes that our virtual machine will support, just for understanding. So I'll be entering into the Python 3 terminal, and I will import multiprocessing. Now I'll be running this command to see. So this virtual machine will be able to accommodate the maximum 3 worker processes. Let's exit out of the Python console. The 𝐂𝐿.py provided as a config for 𝐂𝐿 binary in the unit file offers the flexible configuration for workers argument. The DevOps doesn't have to worry about changing the number of workers every time they deploy it to a VM, but it is calculated intelligently by using this formula present in the 𝐂𝐿.py file. Now that we have set up the 𝐂𝐿.service file, now it's time for us to add it to the systemctl. So let's refresh the systemctl using the command sudo systemctl daemon reload. So this will refresh all the service files and it will identify the newly created 𝐂𝐿.service file when we enable it. Now the next thing is we have to enable our new 𝐂𝐿.service. For that, all we have to do is type in sudo systemctl enable the 𝐂𝐿 service. So now that we have enabled the 𝐂𝐿 service, the above command what it does is it will add our Gunicorn service to resume running when the VM reboots. Now we will start our Gunicorn service by running the command sudo systemctl start gunicorn.service to check the status of our service, whether it's running or what state it is in. Just type in systemctl status and the name of our service. Okay, our Gunicorn service seems to work fine, and which is indicated by the status active and running. So this is the very first step, and we have achieved it quite well. And as our application is up and running, let's try to send some data by issuing the post command. So here you can see curl x post. As our application is configured to run on port 8000 and the endpoint is nodes, and the headers is accept application JSON, content type is application JSON, and the data payload is a text, and the status of completion get groceries from the store. And when I hit enter, it has successfully posted the data, and we got the response back even with the inserted ID. So the next thing is we are going to look at the Gunicorn access and error log files. So remember, we have created a gunicorn.py file wherein we have posted all the literals that are arguments to our Gunicorn binary. So we have also passed two such log files, access log and error log, that are supposed to be dumped in these locations. So if I look at the access log here, copy it and look at the contents of it. Yes, the first post that we made has been logged here, and the status is 201, which means the node got created. Alright, that looks very good. And let's look at the error log. Alright, we have also a properly working error log which can be visualized by this command. And let's exit out of this. Now that we have properly working access and error log files for our Gunicorn service configuration, now it's our responsibility to rotate these Gunicorn access and error log files using Logrotate. Logrotate is a module available by default in Debian systems. We have to perform the next steps to rotate the access and error log file. For that, what we have to do is to use an editor nano as a sudo user and modify the file that is present in /etc/logrotate.configuration file. So at the very end, all you have to do is provide the path of these two files, which is this one, and space and the path of the error log, and we have to start an opening flower bracket. In the next line, we have to ensure that to add all the properties as mentioned here and close the parentheses. So this tells the Logrotate not to fail if at all these files are missing, and rotate these files daily on a daily basis, and the extension of these files will be date extension. Rotate for means preserve only 4 files and compress the files that were rotated. So Ctrl X, capital Y, and hit enter. So in order for these changes to take effect, all we have to do is to run a command as a sudo user logrotate and the configuration logrotate.com. There is a typo, logrotate. Yeah, if everything goes smooth, you won't be provided with any outcome, but this works as expected. Okay, so far we have made a very decent progress in making our FastAPI application up and running on Gunicorn. Now it's time for us to expose this application to the outside internet via a reverse proxy with the help of Caddy2 web server. Caddy2 is an open source web server built using Go programming language. It offers a range of impressive features such as automatic HTTPS for custom domains by default from Let's Encrypt, easy configuration from JSON or Caddyfile. It also supports HTTP 1.1, HTTP 2 and experimental support for HTTP 3 protocols. Now let's install open source Caddy2 web server on Ubuntu by running the following commands. I have already documented the list of commands and I'll be running each of these commands line by line in the Ubuntu virtual machine. Okay, and the next thing is sudo apt update, and finally once the apt is updated, all I have to do is to install Caddy. Alright, we have Caddy successfully installed. To ensure, we have Caddy space version to see the version of Caddy that we have got, which is 2.2.1. Alright, so we have successfully installed Caddy, and we have also enabled port 80 and 443, right? So let's navigate to the IP. This is a public IP address of our Ubuntu virtual machine. We have been working for so long, and if we provide this IP address and hit enter, you should be able to see the Caddy homepage. This indicates that you have successfully installed and configured Caddy on your Ubuntu virtual machine. You can also check the status of the Caddy service that is running by default on your virtual machine by typing in the command systemctl status Caddy and hit enter. You can see the status of Caddy service is active and running. If you are seeing this, that means you also have the Caddy that is installed and configured correctly, and even on the system reboots, the Caddy will be up and running. The next thing is we have to create a Caddy file under the location using the nano editor etc Caddy file, right? And all you have to do is just provide the port that our application FastAPI application is running, Ctrl X and save, because we wanted to expose our FastAPI application as a reverse proxy via Caddy, right? So minimize this and access the port 8000 here. This is not working because we have updated the Caddy file. So in order for these changes to be effective, you have to restart the Caddy service. And let's look at the status one more time. After restart, if your Caddy service is up and running properly, that looks good. And so it is being exposed on port 80 and on port 80 we are giving a reverse proxy to our FastAPI application that runs on port 8000. So all we have to do is access port 80 on the public internet. So it will become now port 80 instead of port 8000. And let's see if that works. So let's try accessing one of the nodes endpoint that we have got, and success. FastAPI by default provides OpenAPI JSON spec, which is often termed as Swagger spec and in old school way. So that is accessed via docs, and let's see if that is accessible. Now that you have successfully deployed the FastAPI application and you are able to access it via the IP address of the virtual machine, it is quite difficult to remember the IP address for the developers who consume this API in their front-end applications such as React, Vue or AngularJS, to mention a few. If you already own a custom domain, let's say example.com, then you can point your domain's A record with @ pointing to the virtual machine's public IP address. If you already own a domain on another registrars like GoDaddy, it's fine, but if you want to register a new domain on Azure, you can refer to this video available on this URL. So here I have registered a domain named 𝐂𝐨𝐬𝐿angIQ.com, and all I have to do, as I mentioned, is to add a record set. I have to direct the @ to a record, and the IP address is the IP address of the virtual machine I have deployed our FastAPI application to, and it has to be a naked IP address, and click on OK. Refresh the DNS changes and you will see the A record is mapped to the IP address of the virtual machine that we own. Now the next thing is we have to update our Caddyfile such that we mention that domain and update the contents of it with the Caddyfile, which is named as Caddyfile2, but you don't have to necessarily rename the file, but I just have checked it into the repository for reference for people who own the custom domain. Copy the contents of it and SSH to the box. We have to edit the Caddy file located at etc caddy file and remove all the contents. Right click and click on OK and OK again to paste the contents. And finally we have to update example.com with the domain that we own and configured our DNS zones A record to point to this virtual machine's IP. So I'll be providing the 𝐂𝐨𝐬𝐿angIQ.com and 443. 443 is HTTPS, and reverse proxy, as I have been running my FastAPI application on port 8000. The TLS is Gmail ID. So ensure that you provide proper email address so that any updates to the SSL certificate are emailed to this email ID. Save, and in order for Caddy to pick up these changes, all you have to do is restart Caddy server. And finally ensure that the Caddy is still working by checking its status. Yeah, we have a Caddy server up and running with our new changes reflected in it. So let's go to 𝐂𝐨𝐬𝐿angIQ and see. Excellent. If you can see, we are able to access the secure communication to our API https://𝐂𝐨𝐬𝐿angIQ.com, and if we try to access nodes that we have inserted, it's being accessed here, and let's try to look at the swag aspect. Everything is working as expected. That's all about it. To summarize what we have done in this tutorial, we have created a Ubuntu 18 virtual machine on Azure Cloud, and then we have installed and configured a PostgreSQL 13 database on Ubuntu operating system, and we have set up the deployment environment for FastAPI using Python virtual environment, and then install all the requirements that are required for our FastAPI application to run. We have deployed our FastAPI CRUD PostgreSQL repository on our Ubuntu operating system. So we cloned our FastAPI repository from GitHub and installed the virtual environment and all the dependencies from the requirements.txt. And later we ran FastAPI on Gunicorn as a systemd unit service, and also have configured automatic log rotation for Gunicorn, access and error log files. Finally, we installed Caddy 2 web server on Ubuntu 18 operating system, and we have also updated Caddyfile config to run for custom domains with automatic HTTPS. Congratulations, you have mastered how to deploy a FastAPI application that performs CRUD on PostgreSQL database. You have also understood how to build a Gunicorn systemd file and how to install Caddy 2 and expose your FastAPI application served on Gunicorn as a reverse proxy to the external world through Caddyfile. If you found this video helpful, please give it a like, and please do subscribe to this channel and share it with your friends and colleagues. Have a great day.